In this lecture, I want to talk about the popular ATA interface, otherwise known as IDE. Now, this is the popular interface that people use to connect things like hard drives and CD-ROM drives to their system. First of all, what do the acronyms mean? Well, IDE stands for Integrated Drive Electronics. And what that refers to is that basically the electronics, meaning the controller card, are actually integrated or built into the drive. I mean, years and years ago, we used to have a separate hard drive controller plugged into a slot, and then to that, we connected a hard drive. And from one controller, you could run two drives. Well, they began installing the controller actually onto the drive and then plugging it directly into the motherboard. And that was the birth of what is called the ATA interface. Now, the term ATA actually stands for AT attachment, and it refers to the old ISA bus that was used on the old IBM AT motherboard, which IBM actually called the AT bus. And by having the controller built in the drive and plugging it directly into a bus slot, you basically had an AT bus connection. So it was called AT attachment. Well, that worked great when hard drives were slow, because the original ATA interface was limited to only 8 megabytes per second throughput. And that was coincidentally the exact same throughput as the original ISA bus connector. That's 1984 technology. You know, nowadays we have drives that are much faster. So what has happened is the ATA interface has evolved over the years. Now, what happened was all of the drive manufacturers got together and created a committee so that they could jointly evolve this interface standard. Nobody wanted to be under control of any one drive manufacturer. And this committee is called the T13 Technical Committee. In fact, you can see the website at t13.org, which I have up on the screen here. And you can see it's described as the Technical Committee T13, which is responsible for creating and defining the AT attachment interface. Now, ATA dates back to the 80s, to the late 80s, early 90s, and has gone through several revisions. They are currently working on ATA-7, which is the 7th revision of the standard. Over the years, as each new version of the standard have come out, new enhancements have been made. And if you look at this website, you can actually download all of the official ATA standard documents, all the way from the original ATA-1, all the way up to the current ATA-6 and 7, which are being worked on right now. Well, the ATA interface has evolved into a 40-pin connection that we see on the motherboard. I have a close-up here of a modern motherboard, and you can see the primary and secondary IDE, or ATA connectors. I should just mention from here on out that anytime I say ATA or IDE, it basically means the same thing. The official name is ATA, but most people call it IDE. That was a term coined by Western Digital's marketing department, and it's just kind of stuck. So it's a popular term, but it is only a marketing term. The correct technical term is ATA. Well, we have a primary and secondary connector, primary and secondary. Notice the arrow here on the board, that's pointing to pin 1. That would be used to orient the stripe on the cable. Also, the 40-pin connectors have a missing pin here, and the missing pin also corresponds to a blocked pin on the cable. You can see the blocked pin right here, and that blocked pin goes where the missing pin is, and it ensures that you don't plug the connector in backwards. Also, many of the connectors have a little notch on them here, and then that would fit in the notch here and here. So again, that also helps so that you don't plug these cables in backwards. The current fastest ATA interface supports speeds up to 133 megabytes per second throughput. That's incredibly fast. In fact, faster than any drive on the planet today. I recently did a survey of all of the hard drives available on the market today, and the fastest drive on the planet, and there's only 2 of them that could do this, would transfer at an average speed of 42 megabytes per second. And there were only 2 drives capable of even that. Now, that's averaging the speed on the innermost tracks versus the outermost tracks, the average speed of all tracks in between. 42 megabytes per second. Now, the interface can sustain 133. What does that mean? Well, what it means is that there's no bottleneck in the cable here. You know, the cable getting the data from the drive to the motherboard is not the problem. The interface on the motherboard or the drive is not the problem either. The problem is it can only read 42 megabytes per second maximum off of the platters of the drive, and that's, again, an average. So bottom line is, if you have an ATA interface on your motherboard that supports 66 megabytes per second, or 100, there is no need to change your motherboard out or buy a card so you can upgrade to the new 133 megabyte per second standard. You will really gain nothing because your drive is actually much slower than that anyway. Even the fastest drives on the planet aren't nearly that fast. Each of these connectors on the board here, primary and secondary, each of those can connect to 2 drives. I have some examples of the cables here. You can look at, I have 2 different ATA cables, and you'll see that each of these cables has 3 connectors on them. Now the 3 connectors are 1 for the motherboard and 2 for the drives that can be connected. So you can connect up to 2 drives to each connector on the motherboard. The 2 drives that are connected are called master and slave. Now, how do you distinguish a drive from being master or slave? Well, there are several ways to do this. The way that it used to be done is to use jumpers on the back of the drive like this. To set the drive as a slave, you would set it to this jumper setting here. As a master, this setting here. And each drive had to be set uniquely. One is a master, one is a slave. If you set both as master or both as slave, it wouldn't work properly. That's how it used to be done. In modern drives, we use a third option, and that is actually called cable select. So here's where the jumpers actually are on the drive, right in here on the back. And this jumper is right here in this position, and the position there is labeled CS. That stands for cable select. Cable select. What that means is that the cable determines which is master and which is slave. Virtually all modern IDE or ATA cables are a cable select type cable. How do you know whether your cable is cable select? Well, there are a couple of ways to tell. Number 1, all cable select cables are color coded. Look at this, or I shouldn't say all of them are, but if your cable is color coded like this, then it is a cable select cable. By color coding, I mean this. Look at the blue connector here. Blue means motherboard, gray means slave, and black means master. So if your cable has these 3 different colored connectors, then it's definitely a cable select cable. You set the drive to CS, cable select, you plug it into this black connector, it becomes master, the gray connector, it becomes slave. So basically all of your drives are jumpered the same way, it's just which connector end you plug it into that makes the difference. Now if it's not labeled like this, then it may not be a cable select cable. In other words, if the cable has no color coding or no labeling as to which is master or slave, then in that case, it's not a cable select cable, and you'll have to make a master or slave setting on the jumper. Now, besides the fact that there are some cables which are cable select and some which are not, there's another distinguishing factor between cables. I'm going to slide these 2 cables under the camera here. The ATA interface is a 40-pin interface. That means there's 40 signals that run the length of the cable. However, there are cables which have 80 wires in them, and there are cables which have 40 wires in them. If you have 80 wires in the cable, yet only 40 holes in the connector, what are the extra 40 wires doing? Well, what they are is grounds. They're additional grounds to provide signal and noise immunity for the cable. Bottom line is, an 80 conductor cable is a quieter, better performing cable. In fact, as part of the ATA standard, they decided that if the interface was going to run at 66 megabytes per second or faster, that means 66, 100, or 133, then you have to use an 80 conductor cable. The old 40 conductor cables like this one will not work. In fact, most drives and motherboards will detect whether you have an 80 conductor cable or not, and if you do not, they will not allow a speed higher than 33 megabytes per second transfer speed. So, bottom line, you could always take out a 40 conductor cable and replace it with an 80. You can always do that. Because of that, I only buy 80 conductor cables personally. Even on older, slower drives, they work great. Also, all 80 conductor cables are cable select cables, which means you can set the drive to cable select rather than having to do the individual master and slave settings. So, tip is, for me, is to use only 80 conductor cables. If you are using the older 40 conductor cables like this, then you need to make sure that you're only using them on older, slower devices. Now, I said older, not necessarily. Most of the, for example, CD-ROM drives, DVD drives, and that may not utilize a transfer speed faster than 33 megabytes per second anyway. If the drive is incapable of supporting a transfer speed faster than 33, then you can get away with still using the 40 conductor cable. I prefer an 80 because it's a little bit more immune to any noise or other problems, but the 40 will do in that case. So keep in mind that the 80 conductor cables are more expensive. Generally, when you buy a motherboard, it'll come with two cables, one of them being an 80, the other being a 40. I have seen a lot of the newer CD-ROM and DVD drives do transfer faster than 33. They transfer at 66 megabytes per second or even 100. In that case, you really should have an 80 conductor cable attached to those drives. If you don't, you will not get the full transfer speed capability of the drive. Even though the drive may not be able to sustain a transfer that fast, all of these modern drives have built-in buffers or caches. And what can happen is it can do a burst transfer from the cache to the motherboard at the faster speed. So there is some reasoning for having the faster speeds even though the drive may not sustain that transfer. Okay, now that we've taken a look at the cables and conductors here, I'm going to take a look at this CD-ROM or DVD drive. And on the back, you'll see a similar arrangement of jumpers on this drive. And these jumpers control whether the drive is master, slave, or cable select. So again, same way as it's done on a hard drive. If you're using a cable select cable, set the drive to cable select and install it that way. Currently, we're at 133 megabytes per second maximum for the ATA interface, ATA-7 it's called. That is probably the end of the line for the ATA interface as we know it. The problems are that it's difficult to get that interface to transfer faster than 133. They had to redesign the cable once, going from the 40 to the 80 conductor. Problem is, now we have timing issues with the cable. Now, one rule about these cables is that they have a maximum length limitation of 18 inches. That means from end to end, this cable should not be more than 18 inches. If you have a cable longer than 18 inches, especially if it's one of the 80 conductor cables, using the faster transfer speeds, you're risking corrupted data on your hard drive, system lockups and crashes, blue screens. I mean, that's what will happen when you have unreliable transmission across this cable. The engineers who designed the standard, those who are part of the T13 organization, have done the research, and they say that 18 inches is the maximum. So if you've gotten away with something longer, congratulations, but it's not the best way to build a reliable system. I recommend staying away from the longer than 18-inch cables. Somebody else said, well, why would they make longer cables if it violates the standard? I thought about it for a second and answered back, yeah, that's a good question. I want to know the answer to that too. Probably because people will buy it. So just because somebody sells something doesn't mean it was valid or that it conforms to the standard. Now, the latest rage with these cables is to have them be round to maximize airflow through the system. The rounded cables are fine as long as they're 80 conductor and as long as they're not longer than 18 inches. If you really want the rounded cables, one thing I would recommend is simply fold up the cable yourself. You can fold it up very easily, like so, and then wrap it in electrical tape. This is a way to minimize the diameter of the cable, wrapped in tape, and it would maximize the airflow through the system. So there's not much to making these rounded cables. There's no need to cut up the individual wires in the cable in order to do that. So it's a cheap way to get that same effect. In any case, we've taken a look at these different parallel ATA standards, but what's coming in systems down the road is serial ATA. We had to go from 40 wires to 80 wires. What's next is actually to go down to something like 6 wires. That's right. The cable in your future hard drives, maybe a year or so from now, are going to be a very thin, light, and small round cable. And this is called serial ATA. With serial ATA, they've been able to achieve transfer speeds of 150 megabytes per second initially, going up to 300 and then 600 megabytes per second in the future. And it's part of that serialization of the PC. A lot of the buses in the PC are going from parallel to serial because it's more efficient to do it that way. They have less timing problems. Those cables can be longer without causing problems.